Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 474, lexicographically smallest palindromic permutation greater than target. Hit the like button, the subscribe button, join me on Discord, let me know what you think about this one. First of all, there's this part about strictly greater than. If you watch me solve it anyway, I ignore it because we can always just make it the next thing very easily, and I'll show you a trick that I did during this one, but there's so many other ways of doing it. The second part is, of course, the palindromic part, which is a little bit tricky, but also you can definitely do a pre-filter on S, meaning that you just check whether S is the input is palindrome, or it can create a palindrome in like very quick time, right, linear time really, and that'll give you, so then now, for example, this is not palindromic, so you can just do a filter and then just return empty immediately, right? This allows you to kind of get rid of handling special cases inside the core logic. You just do it in the like a pre-filter thing, if you want to call it that. Okay, let's ignore the strictly greater part, just because there are tricks to do. You could increment or whatever. We'll talk about it later, but yeah. But let's get to the lexicographically smallest part, right? And really, this part is not too tricky once you kind of realize what's going on, and the key part is also just like thinking about complexity and stuff like that. But yeah, but okay, but I think for this one, the palindrome almost doesn't matter that much. When I was solving this, I was trying to think of a similar problem that I've done, and I have some like recognition of it, but I couldn't find it, or maybe I'm just making things up, right? But yeah. But basically, you have some things, right? Let's say that's your target, and then you have numbers, yeah. And the S actually doesn't really matter per se, because it can be reduced to, and actually, let's just add a C, right? You can reduce to just like a number of characters kind of thing, right? So maybe 2 Bs, I miscounted really, but maybe that's fine. 1 Cs, and I don't know, 2 Ds, right? And keeping in mind that, of course, in a palindrome, you can have at most one odd thing, right? I'm not gonna go over it that much in this video because this is a Q4. You really should know how palindrome works, at least the very basic. There are probably videos on it. I've definitely made videos on similar palindromic related problems, but today just gonna keep it short, keep it quick. So I'm going to assume that you know how to filter for a palindrome, which is just that it has at most one character or one item in which there's an odd occurrence, right? Frequency. Okay, so then now there really are only 2 cases to kind of match this in these things, and that kind of makes it much more straightforward. The only case is that whether how much of the prefix so far is matching, right? And what do I mean by that? What I mean by that is because, and maybe with characters it looks a little bit awkward. I don't know. Let me know in the comments. But the way that I think about it is also like with numbers, right? Because let's say if you have, without worrying about palindrome for now, you have like A and C, right? If this is A and C, then in a greedy way, we already know that B is not equal to C, obviously, but also that C is already going to be the next biggest. If you do them in order, if you have AC, that means that everything else should just be sorted, because we already know that if it's not sorted, well, I mean sorted given the palindromic constraint, right? Because obviously this matches the last character C, and this matches the last character A, right? So okay, but everything else, going up to, for this problem, going up to the middle should be sorted, because that's just the way to get it, right? Yeah, that's the way to get this lexicographically smallest, assuming that it's not the prefix. Okay, so then what happens when you do match the prefix, right? Well, oops, how did that happen? Well, then you just do a recursion and do the same thing, and if you can look at it this way, right? Because let's say we did do C. If we have a C here, because we have a C here, we would never do D, right? Because well, okay, this is a kind of a terrible example because C is actually the medium thing. But let's just let me change this real quick. Instead of 1, we have 3 of these, right? So we have at least 2 of these, but you know, n is also odd, right? I don't know, that 3 looks weird, so let's make it 5. Maybe that's slightly less weird, whatever. But yeah, so that means that this could be C, right? And there's still a palindrome that has this with C, right? But this also means that even without worrying about this thing being odd, without C being odd, D could never be the smallest, right? Because if C can give you a palindrome, then whatever it is always going to be your next biggest, possibly, and D could never be your next biggest because it's always smaller than C, right? So okay, so that means that for every character or every index really, if we can only have 2 branches, right? Here we either follow the prefix or we don't follow the prefix. And when we don't follow the prefix, where you said this is just going to be sorted, right? In a way, or like lexicographically smallest. So for this particular one, it'll be sorted, and then this will be just like the rest of the thing, right? Because this is a palindrome. Otherwise, then you have B, and then now we do the same thing, right? So yeah, we get the next character, so it's either B or maybe the next one, which is C, and then this is sorted again, right? Up to the middle, right? And if you kind of write it out, and I kind of drew it a little bit in reverse, you may say, oh, well, in that case, you have a character, a string of length n, then isn't this like 2 to the n because of the tick no tick? Well, no, right? Obviously not, because this thing, just to be clear, I mean, I don't know, maybe some of you do, because sometimes I'm saying that not because, you know, whatever, but because I sometimes do the analysis wrong, and then I'm like, oh, isn't it 2 to the n? I'm like, oh wait, no. The reason is because, of course, if you're at this stage, notice that there's no branching, right? So that means that this always just goes one thing. There's no branching. This as well, right? No branching. So that means that you know, for each index, for each character, for each index, for each character, we are only going to create one thing, right? And you could say that maybe this is, you know, if you do this in a sloppy way or whatever, doesn't really matter. You can say this is O of n. And if there are, for each character, we create one of these branch, that means that there are O of n number of branches, right? And so in combination, this is going to be O of n squared. Maybe times some constant that we could talk about. But just thinking about this, knowing that n is equal to 300 means that we are more than fast enough, per se, right? Okay, so that's kind of the key thing to doing it. Once you kind of realize this, then yeah, then you should be able to, I mean, then it just becomes an implementation problem, right? Of course, there are tricky things about this particular problem in terms of implementation, which is why I got 2 wrong answers, but that was just me being sloppy. But the core algorithm part, this is it. It's just this idea of, you know, there are only 2 things that you can try, but this one, the branch ends, so it's just, you know, linear kind of thing. It becomes quadratic and square. And with that, we can look into the code. Yeah. Oh, I think, let me go back for a second, actually. I think one more thing that I would say is that I kind of drew this with the branching first. I don't know why I did that. But the key, one more thing that I would say is that if you do this in order, you can just get the first result, right? Because if you try the prefix first, then now it is going to be in order, right? And then we'll go over the cases, which is not, but yeah, but that's just kind of what I want to go over, is that you can make it so that you just get the first one, though. It's not even necessary, I don't think. per se, because complexity wise it doesn't make a difference. But yeah, so I do the recursion. If I found the solution, or if I don't find the solution, I return empty string. Otherwise, I return the solution. So the hack that I mentioned is that for target, I do the count on target first, but I just add a z at the end, right? So that it has to be this, or so it has to be equal to this or next. So it kind of made it easier to do, because you have to be strictly greater than. But if you add a z to the end, then it's not going to be strictly greater than, right? If it's equal to. So you have to be, or let me rephrase this. When you add the z in the end, it has to be, if you set it so that it's equal to or greater than in the way that you construct your code, then now it has to be greater than or equal to this with a z at the end. So that means that it's going to be strictly greater than the previous target without the z at the end. That's basically it. Okay, and this is the frequency. We set up the frequency table, right? Just frequency counter, frequency map. And this is just to count the number of odd. It's a one-liner to count the number of odd frequencies. If there's more than, if there's two or more, specifically how I wrote it, then it's not possible. And then we return empty string. So that the rest of there are two reasons for this. One is a little bit performance, right? Because this is cheap, we check it and we're done. But the more critical part is that now we know that everything that we do in the iteration afterwards, it is possible to create a palindrome, which is an invariant that we want to keep. So we do the recursion as I mentioned, and in the recursion, we also have a global, a local global, if you want to call it that, global to the function, a found thing, right? So if index is equal to n2, and this is just, I don't know if this is quite the cleanest way of me handling the both the case of an odd and even palindrome, right? Meaning a palindrome of odd number of characters or even number of characters. I don't know, but you can just do the math really quickly, right? If because we're only constructing by half, so we only need half the index, and that's basically why I did it this way. Yeah, and I also remember that there's no memorization or anything, so the states don't really matter. I just kind of have a character for number that characters that we have to left to do. I don't know. Things are a little bit. I wouldn't say this is the cleanest implementation, by the way, but I'm just going over it. Hopefully, once you understand what I'm doing, write your own, write it cleaner. This is contest code, but yeah. But for left, I actually keep the parity. So mostly of how many characters are there. And I think if I did it that way, then it would have been a lot cleaner. But in any case, yeah, it's just to keep the parity. So if there's no middle character, I just kind of, and let me actually go a step back a second and construct what these parameters mean. Index is just the index of the character that we're constructing, right? Prefix is basically whether we're matching the prefix so far. Current is actually like an array of all the characters that are in the prefix that we constructed so far. Not this prefix, but just like in general, so that if we get to the end, then this is what we're doing. Left is whether, it's just a thing that I use to track whether it is odd or even, and we'd have to keep track of the middle characters. And yeah, so after we finish half the string, then we have to check whether this is valid. If left is greater than, left is equal to 0, there's no middle characters, so we just, we know what the current is, so then we refract it to the half, and yeah, and if there is a middle character, we find the case where this is it. Maybe there's a cleaner way to do this, because you probably don't need to do this every time. We know what, we probably could cache this, is what I mean. But in any case, that's how I did it. And with 300 squares, not too worrying, but yeah. Anyway, we construct the same thing, but with an extra middle character. And I just do a simple string comparison, character by character, right? If it's greater than or equal to target, then we set it to found, and then we just return, right? And that's it. This is our checker, and yeah. And the reason why I do it like this is because then we can always only have one place to do the check. Okay, so yeah, this part I just make sure that I early terminate, right? Meaning that if for whatever reason this gets called while found is not none, then we just return because we're done, right? We don't have to do anything more. Okay. All right, let's go with the easier way first, which is that if we don't have the prefix, meaning that this is the case where, you know, if we kind of go back here, if we don't have the prefix, meaning that if we are in this thing, well, that means that the rest should be greedy, and if the rest is greedy, then that's what we did. So we greedy the rest. And that's just looking at the frequency table. We sort by the keys, you know, alphabetically. Basically, is what it is doing. Just can put everything in current, right, with the count, and then yeah, this is the part I actually got a couple of wrong answers to, just because I underestimated this part and I was very sloppy about it. But the thing is that we now want to recurse on updating f of k, so that I don't know, this is silly. I think the way that I did it is not very smart, but in any case, that it makes it so that this part gets triggered with the correct character, but with wrong. I did it with wrong answers, so I don't know. But yeah, so if this is odd, then this has 1 for it to hit there, and then we just do a recursion. And this is a tail recursion that only happens once, right? Because this is already, we go directly to the middle. We always skipped all these things, go direct to the middle, no prefix. We already updated the current array, and this is whether, whether there is a middle character or not, and that's it. Okay, so that's the, if the prefix doesn't match, then we just greedy the rest. Otherwise, if the prefix does match, then what happened? Well, if the prefix does match, then we have to, at first, try to keep the prefix from matching, right? So we know what it is, which is target of index. So if we have at least 2 of these, then we could create a palindrome, right? From top, beginning, and end. We subtract by 2, and then and this is a regular, what you might call it? Man, I am really bad. Branch and bow now. What's that fancy word for recursion? I don't know. But this is basically the recursion. I'm blanking on a name for some reason today. My apologies. It is already 3 a.m. But you know, but the thing with you know, this recursion is that you have to undo it, is my point. Backtracking. I think backtracking is what I'm trying to say. Okay, yeah, it is backtracking. I was blanking out for a bit. But yeah, basically you change the states. You make sure that you revert the states by updating current, but also pop, and then just try it, right? And this is basically, yeah, next character. Again, I don't know how I feel about that part. But the prefix is still true, and you updated current here, right? So yeah, and then you try it. If this is possible, then we just return, right? We already updated found. Otherwise, then we try not. And you probably could be a little bit smart about this, but what I do is that I just get the next character in which f of c, where the frequency is greater than 2, right? If the frequency, yeah, and that's it, right? Because we're not trying to middle characters. If we are in an odd palindrome, and where the middle character, this would get picked up by here, so we don't have to worry about that. So we only have to check for 2. Again, this is I think this is not necessary. Right? I think actually I did it. I think this is actually imprecise. That's one. I think the backtracking part is actually not necessary, because if C is available, meaning the next character that's bigger than the target is, and this doesn't give you an answer, then nothing will, right? So that's why I changed this to return. I don't know. I mean, I guess the other one is still, like, you could try other ones and it would just be false. So maybe that, I don't know. It's a little bit awkward, but also that I think if you try greedy, it should mostly work. So maybe that's why a little bit bad. But yeah, But otherwise, you did this to force. You go to the next index, and this, of course, actually constructs the greedy for you, because the next index will branch out to either here, or if you're already in the middle, then it'll just do, you know, one of these two things. So that's why, yeah. And that's it. That's all there is to this code. I just made a couple of mistakes on this part. You could watch it live. Nothing, like, I don't even know if it's worth mentioning. I just kind of rushed it, and then I didn't consider the middle case clean enough twice. So, but yeah, so what's the complexity here, right? I already showed you, right? It's going to be n squared. That's it, right? Yeah, that's all I have for this one. Let me know what you think. I mean, you want to say it's because of this loop, it could be n squared times a or alpha, where alpha is the size of the alphabet or something. But for this one, it is fast enough in either case. But yeah, that's it. That's all I have for this one. Let me know what you think. I'm gonna make it slightly smaller so you could see all of it. Well, I mean, not all of it, but more of it. Let me slowly scroll down so you could kind of see the code, whatever. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live in the contest now. Okay. How am I doing on time? That took a while, actually, even though I knew roughly what I wanted to do. But it is what it is. Okay. Let's take a look. SN target, each of length n, consisting of lowercase English letters. Lexicographically, small string that's both a palindromic permutation of S and strictly greater than target. Can we do something similar? I feel like we did this problem, right? Or am I just like clunking out? Like, did I make this up? We literally did this. Am I thinking about someone crazy? Is that why people got in? Well, people getting in a minute is probably just cheating. But still, what is the problem I'm thinking of? I'm not gonna lie. I'm pulling up Leetcode to see like random or recent problems. This is what I would do during the contest if it happened. So I don't know. But I mean, I don't remember enough to not solve it. So maybe that's, you know. But like, I feel like that was like in the last week or two, right? Or maybe 3 weeks, something like that. Lexicographically smallest. Is it not this one, maybe? Okay, so this one's palindromic. So it wasn't that one though. It was a hard that I've been thinking of, because I had to do it with whatchamacallit, with digit DP. Maybe I am confusing things. Which is okay. I don't think I would have remembered it was that long ago, but so maybe I am just forgetting. Count binary palindromic numbers? No. Was it this one? Maybe I was thinking about this one. Okay, I mean, I don't know. I feel like I did something like that. No, I mean, that's the one I'm looking at now. But next special palindromic number, maybe that's it. No, it wasn't it. Maybe it is the same idea. I don't know. All right, let's actually solve the problem instead of trying to figure out what it was. Is this after people remove cheaters? People are so fast. I don't know. Okay. So it's a permutation of this, right? N is 300, so we could do like n square log n or something. Okay, so first of all, I guess we have to see whether this is a palindromable thing, right? Why is this indented really? So if is it count or something or whatever? Let's just do it, right? So we mod 2 for key value and f of items. If this is greater than equal to 2, then we just return empty string. That means that we have number of odd count things. Okay. How do I want to write this? I mean, for every one of these, it's either you do the prefix or not. I mean, it's definitely digit DP, but it's just like so annoying that I don't want to write it. That's all. Okay, fine. How do I do it again? So I mean it. So prefix, right? I forget. So prefix. We have the current. I mean, I guess I'm just thinking for the special cases right now for the odd, the middle character, which I guess is the tricky part. I think this is otherwise fine. It's for every one you either tick. So it's tick, no tick, right? Yeah. So of course you have index as well. I just forgot. Yeah, it's tick, no tick, and once you whatever, then it's whatever, right? That whatever is doing a lot of work, but okay. I mean, this is really a for loop, but I'm writing it recursively. So okay. I mean, I'm gonna get this, but it's gonna take me a bit. Okay. It has to be strictly greater than target. Okay, that's fine. It's a little bit annoying, but fine. We can just I think for now I'm gonna ignore that for now, actually. Okay, fine. So then now we'll end. We only need half. How do we do half? That is the thing we did the palindromic thing, didn't we? Because then now, how did I do it with the palindromic thing? That's the one with the numbers that I did look up. I forgot how I try to do it. Because I did it one way and it was just like a lot of tracking. There's a lot of weird thing with zeros on that one actually. Because I think there was a non-zero palindromic or something like that. So maybe it doesn't come into play here because I think there was a lot of zero handling. Okay. And n index is not equal to n then, right? Is equal to n over 2 or something. Yeah, this is doable but very annoying. I mean, an hour should be doing it, but just annoying. Then now we can do what? How do we want to write this? Just write anything really. So this is 11, it'll be 5, so that's okay, that's good for the middle. Also I reused F, that's not good, I just got go. I don't know why, because I used F for frequency. So then now F really only has one thing left. Right? So yeah. We could even just do this. I guess it doesn't matter. If left is 0 to 0 character, then we just take the current. It should be okay, maybe. Oh, no, prefix does it. Okay, fine, yeah. Else, why is the indenting off sometimes? Okay, else, what is going on? Why is the indenting so off? What happened? What happened? Okay. I guess I could put it else here. There should be like one character left, right? So what's that character left? That's whatever's in F. Alright, actually you gotta add items, key value in after items for if we is equal to 1. So we want to let's just do something like this, right? I think that's right, maybe not, I don't know. Okay. And then we return. Otherwise, we just, every recursion, if found is not none, we just return. It should be the first one we find, right? And then now we just take, okay, so if prefix we take, try prefix, try not, otherwise we greedy, right? Else greedy the rest, right? Oh yeah, I was thinking of recursing, but it doesn't even make sense. So this would always just greedy the rest, because it no longer is for our prefix, because the prefix should be matched. Yeah, because the prefix the rest only matters if prefix matters. Okay. Yeah, because we already established the thing. Okay, yeah. Okay, then now for kiwi and after items, let's sort this so keys is sorted. Code. Yeah, it should be good. Well, the handling the odd case is weird, but yeah. Okay, so okay. This is always just more code. It's not. Okay, so if it's even, then we just put I guess we can always just do it this way. Yeah. That should be fine, right? I don't know. Well, just we should be able to go. Basically, go straight to an E2 force. Current. And then it is just whether n mod 2 is equal to 1, right? Or just n mod 2 really, right? Maybe. Prefix is true. Current is empty array. Left is n, right? Or n. No, left is, yeah, left is n is fine. Maybe. I don't know. I guess it depends on how we do prefix. Okay, so then now if found, return found. Maybe we'll write it the other way. Okay. This should not do anything because we didn't fill in this part, but okay. So make sure my syntax is maybe okay. Okay, so now this is the part that we branch, right? Okay, so we try prefix me. Okay. Yeah, okay, fine. So if prefix, then target of index, we try target index, which is the prefix, right? So if f of is greater than equal to 2, because we don't consider the middle until here, so it has to be greater than equal to 2. If this is greater than equal to 2, then we try it. Right. And this probably could be optimized, but still. Okay, so then now we just try the next smallest number. This maybe could also be optimized, but it's fine. So the next one that's bigger than whatever, right? So for C in range from f of not f of target of index plus 1. Well, yeah. So this all the way to z inclusive. If f of c is greater than 2, then we just go with it. yeah, else we, oh, okay, not that, but okay, so we just go index +1, force, current, left -2, we do f of c, I guess, but it should be that if found is none, then we just return, right? Because that means that, I mean, you're not going to get another answer of a bigger thing, I don't think. But maybe I'm wrong on that, so we can just try it, I guess. I don't know. Alright, let's see. I mean, also like, I thought first is the next iterator. Oh, I guess it's just next, maybe not first. I always forget. Okay, we got one of these things right, so that's good. This one is no bueno. I actually, I mean, I didn't do the strictly graded part, so but not having an answer is actually not great. But why is that? Let's see. Lucky is small though. It's good. I mean, it's good that we're able to test this. So okay, so a b, so that's already good. So that, are we here? Okay, so we are here. So that means that it's not calculating correctly. Okay, so left is 0. So a b. Oh. No, I made it so that oh, I'm dumb. I mean, I meant to put this outside after I kind of overlapped them, but then that's a mistake. Okay, so this is good. Maybe we're even done. Now all we have to do is I think all we have to do is just add like a proxy thing. Maybe that's good enough. I don't know. Okay, well, apparently not. Why is that? Well, we know that ABBA wasn't going to be good. And I mean, we want to get the next one, but why wouldn't it give me BAB? Okay, let's see. So prefix, we try it. If it's good. Oh. If found, we return, or it's not none, then we return. But that should not have happened. Oh, well, okay, I see. This is a bad typo, actually. Do I have it on the other thing? No? Huh. Okay. Let's see. Nope, still didn't fix it. But that would, I mean, that's a necessary fix anyway. But it's pretty not great. Okay, so it should go here, and then it should go to B, right? So the fact that it doesn't go here is not great. Let's do try not. See if it goes there. Okay, it does go to try not. But oh, I'm dumb. I wrote it this way, but I forgot to change it back to a character, so it probably wasn't matching correctly. Okay, so that's good. Honestly, I'm not confident about this this solution. But okay. Oh, I guess I should try to at least get a big thing out here. Actually, I just whatever. 300, I think. I mean, maybe that gives me a trivial solution. Oh yeah, I mean, I was thinking about why it's not working, but I guess there's no way for that to work. Or like, you know, because there's no next solution. Okay, so that's good and fast. B is in the middle. No, I mean, I don't know. I don't think that's a great example for time limit, but at least seems to be roughly accurate. Oh no. But there is an invariant here where left is equal to 1, but maybe I'm not right for 3. Target should not matter, but also I left in a standard output, so maybe that would. Anyway, I mean, I feel like there's a minor inaccuracy somewhere. It's not that. And we got 45 minutes. It should be good. Where's my print statement though? Oh. Okay. Okay, let's just print it out then, right? Because if left is equal to 1, then F should be some stuff. N is equal to 2. Oh. No, I mean, I see why. Okay, so here, yeah, it's fine. But if there's a prefix, you can try either one, then do you agree? No? Okay, but I mean, there is an extra one. Oh, this part, I didn't really think about it correctly. No. This is, okay, I see. I messed up on that part. Oh, yeah, no, this is times 2. Okay, that was a silly mistake. Or maybe, maybe this is more precise. Okay, what is, they don't even tell me the answer. Yeah, they just tell me that I threw an exception. Okay, fine. But it seems okay. I definitely, wait, what is the N? No, that looks reasonably correct. Is it? N is here. Oh, no, yeah, that should be correct. Okay. Should be more correct anyway. Well, alright. Seems like I'm returning something weird. So that's not great. And also I left the print in here still. Okay, I mean, I think we're conceptually correct, but not actually correct, which is the more important part, but that's not great. Okay, so we print this. I mean, well, there are only 2 R's, so how did R get? Oh, is this? No, this is right. No, oh, I voted and I still got it wrong. Larry, what are you doing? Larry, what are you doing? We minus, oh, this is not subtract from. What are you doing, Larry? That's just inconsistent. I think that's what I wanted to do. But also maybe just set it to, whatever. Larry, what are you doing? What are you doing? What I'm doing is that I'm rushing and not thinking, because that didn't really make sense. Like maybe it was, if it was right, I just did it by accident. That just didn't make any sense. Okay, print statement. All right, take out the print statement. All right, that's already yeah, in the middle of everywhere too. So, all right, okay, good. All right, I mean that wasn't even that hard. I mean it was annoying. Like the difficult part was in the implementation for sure, but like I feel like I messed up on the easy part and not the hard part, because like I think that's the part that I'm like annoyed about, because solution wise whatever, right? But like I got 2 wrong answers on, is it 2 wrong answers? Yeah, 2 wrong answers, and they're both the same reason. I just messed up this part. This was 2 wrong answers, right? So that's, I mean, even 1 wrong answer, I don't know, maybe it's fine, but the second wrong answer is doubly not fine, right? So I yeah, I don't know why. Oh, well, I guess it wasn't this statement, it was this statement, but I just didn't, I rushed it a little bit and I didn't think about how to actually resolve it. And I wrote this thing which didn't make any sense. Okay, but I don't know. It is what it is. It's fine, but it's just still very silly, I suppose. But I mean, I'm still recovering from my race, so that's my excuse. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.